Solving finite geometric series. Geometric series. This is the indicated sum of the terms given geometric sequence. For a finite geometric sequence, like 3, 6, 12, 24, 48, its finite geometric series will be 3 plus 6 plus 12 plus 24 plus 48. In geometric series, let's say we have S of n be the sum of the first n terms of a given geometric sequence. Thus, we have S of n equals a sub 1 plus a sub 2 plus a sub 3 plus so on and so forth plus the last term or the a sub n. And let us say this is our first equation. From this given equation, this can also be expressed as S of n equals a sub 1 plus a sub 1 times r, because a sub 1 times r is also the a sub 2, plus a sub 1 times r squared, which is also the a sub 3, plus so on and so forth, plus until a sub 1 times r raised to n minus 1. And let us say this is our second equation. Let us multiply the second equation by r. So we have r times s of n equals r times s of n. A sub 1 times r is equal to a sub 1 times r. A sub 1 times r is equal to a sub 1 r squared. And the same thing with the others. We have plus, so on and so forth, plus a sub 1 times r raised to n minus 1 plus a sub 1 times r raised to n. And let us consider this as our third equation. And now we subtract the third and the second equations. So again, our second equation is S of n equals a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus so on and so forth plus a sub 1 times r raised to n minus 1. And our third equation again is r times s of n equals a sub 1 times r plus a sub 1 times r squared plus so on and so forth plus a sub 1 times r raised to n minus 1 plus a sub 1 times r raised to n. Remember, in subtracting, we change the sign of the subtrahend. So between these two equations, our subtrahend will be r times s of n equals a sub 1 times r, and so on and so forth. And then after we change the signs, we need to add instead of subtracting. So let us now subtract these two equations. So again, we have s of n plus negative r s of n, we'll just copy. So we have s of n minus r times s of m. A sub 1 will just be bring down, and then we have a sub 1 times r plus negative a sub 1 times r, so it will be cancelled. And then the same thing with a sub 1 times r squared plus negative a sub 1 times r squared will also be cancelled until we have to bring down the a sub 1 times r raised to n. But this time, since we change the sign of this, we'll now have here negative a sub 1 times r raised to m. So therefore, we have here s of n minus r times s of n equals a sub 1 minus a sub 1 times r raised to n. And then we simplify both sides of the equation. So in this case, on the left side, we can notice that we have a common factor, which is s of n. And on the other side, our common factor will be a sub 1. So let us now simplify. So our left side of the equation can be simplified as 1 minus r times s of n. So as we're going to check, s of n times 1 is s of n, S of n times negative r is equal to negative r times S of n. And on the other side, we can simplify this as a sub 1 times 1 minus r raised to n. So if we're going to check it again, a sub 1 times 1 is a sub 1. A sub 1 times negative r raised to n is equal to negative a sub 1 times r raised to n. Since we're going to find for the formula in finding the finite geometric series, we need to eliminate 1 minus r besides our S of n. So what are we going to do is we apply MPE, we multiply the whole equation by the reciprocal of 1 minus r, and that is 1 over 1 minus r. So 1 over 1 minus r times 1 minus r will be cancelled. So the remaining on the left side would be S of n equals, we have a sub 1 times 1 minus r raised to n times 1 over 1 minus r will still be equal to a sub 1 times 1 minus r raised to n over 1 minus r. So therefore, our formula in finding finite geometric series, if our r is equal or not equal rather to 1 and our a sub n is not given, or the last term is not given, will be S of n equals a sub 1 times the quantity of 1 minus r raised to n over 1 minus r. So from the given equation that we have solved, let us get another formula. So again, we have S of n equals a sub 1 times the quantity of 1 minus r raised to n over 1 minus r. And then, we can distribute our a sub 1 to the terms inside the parentheses. So we have a sub 1 times 1 is a sub 1. A sub 1 times negative r raised to n is equal to a sub 1 times r raised to n. So negative a sub 1 times r raised to n. And then we copy our denominator, which is 1 minus r. So again, we have a sub 1 minus a sub 1 times r raised to n over 1 minus r. And then our r raised to n can be expanded as r raised to n minus 1 times r. So if we're going to rewrite this, a sub 1 minus our a sub 1, and then we have here an expanded form of r raised to n, which is r raised to n minus 1 times r. Remember, our r here has an exponent of 1. So negative 1 plus 1 will be cancelled. The remaining will be n. That's why this is just the same of our term here over 1 minus r. And we all know that this a sub 1 times r raised to n minus 1 is already our a sub n. So we'll just replace this by our a sub n. So we have S sub n equals a sub 1 minus, again this one, a sub 1 times r raised to n minus 1 is already our a sub n. And then we copy our r over 1 minus r. So this is now our formula in finding our finite geometric series if our r again is not equal to 1 and our a sub n, or last term, is given. If r equals 1, then our sum will be S sub n equals a sub 1 plus a sub 1 times 1, 1 refers to our r, plus a sub 1 times 1 squared, plus so on and so forth, plus a sub 1 times 1 raised to n minus 1. Or this one can be simplified as a sub 1 plus a sub 1 times 1 is equal to a sub 1, 1 squared times 1 times a sub 1 rather is equal to a sub 1 plus so on and so forth. A sub 1 times 1 raised to n minus 1 is still equal to a sub 1. So given this, our S sub n will be equal to n times a sub 1. So this will be the formula in finding geometric series given finite geometric sequence. That is, S sub n equals n times a sub 1. where n refers to the number of terms and a sub 1 is the first term. What if our r is equal to negative 1 and there would be an n which is even number? So we have s of n equals a sub 1 or the first term plus a sub 1 times negative 1 because our r is negative 1 plus a sub 1 times negative 1 squared plus a sub 1 times negative 1 cubed plus so on and so forth plus a sub 1 times negative 1 raised to n minus 1. So if the given value of n would be an even number such as 2, 4, 6, 8, and so on, this will be the given equation. So you will have a sub 1 minus a sub 1 because a sub 1 times negative 1 is negative a sub 1. Negative 1 squared is equal to positive 1 times a sub 1 is positive a sub 1. Negative 1 cubed is negative 1 times a sub 1 is negative a sub 1 plus so on and so forth plus a sub 1 minus a sub 1. So in this given, we can now cancel a sub 1 minus a sub 1. Same thing with a sub 1 minus a sub 1 and a sub 1 minus a sub 1. Therefore, the sum of a finite geometric sequence if our r is negative 1 and our n, or number of terms, is an even number, it will always be equal to 0. On the other hand, if r is equal to negative 1 and our n is an odd number, so we have s of n equals a sub 1 plus a sub 1 times negative 1. Again, our r is negative 1 plus a sub 1 times negative 1 squared plus a sub 1 times negative 1 cubed plus so on and so forth plus a sub 1 times negative 1 raised to n minus 1. If n is an even, rather an odd number such as 1, 3, 5, 7, and so on and so forth, we can now find it as a sub 1 minus a sub 1 times negative 1 is negative a sub 1. Negative 1 squared is positive 1 times a sub 1 is a sub 1. Negative 1 cubed is negative 1 times a sub 1 is negative a sub 1 plus so on and so forth until we have a sub 1 minus a sub 1 plus a sub 1. So in this case, we can simplify this by cancelling a sub 1 minus a sub 1, a sub 1 minus a sub 1, and the same with a sub 1 minus a sub 1. So the remaining will be a sub 1. So in finding the sum of finite geometric sequence, if r is equal to negative 1 and our n is an odd number, it will always be equal to a sub 1 or the first term. Let us now have examples. Example number 1. Let us find the sum of the geometric sequence 2, 6, 18, 54, and until the a sub 5 or the fifth term. So of course, our given, our 2 will be the a sub 1 or first term. Our r is 3. That would be obtained by dividing the second term by the first term. So 6 divided by 2 is equal to 3. And we have our n, which is equal to 5. What we need to find is the sum of the 5 terms. So s of 5. To find this, we have the formula s of n equals a sub 1 times the quantity of 1 minus r raised to n over 1 minus r. So since we don't have here our last term, we use this formula. So by substitution, we have s of 5 equals 2 times 1 minus 3 raised to 5 over 1 minus 3. Simplifying this, we get first 3 to the 5th power. So that would be 3 to the 5th power is equal to 243. So 2 times 1 minus 243 over 1 minus 3, or that is already negative 2. Then simplify 1 minus 243. It will give us negative 242. So we have here 2 divided by negative 2 will be equal to negative 1. And then negative 1 times negative 242 will be equal to positive 242. So the sum here will be 242, or the sum of the 5 terms will be equal to 242. Example number 2. What is the sum of the first 5 terms of 3, 6, 12, 24, 48, 96? So our given will be, our first term or a sub 1 is 3. Our r, so 6 divided by 3 is equal to 2. And we need to find for the sum of the first 5 terms. So we have 3, 6, 12, 24, and 48. So the first 5 terms will have 3 up to 48. So we have a sub 5, or the last term here would be 48. What we need to find will be the sum of the first 5 terms, or the s of 5. To find this, we use the formula of s of n equals a sub 1 minus a sub n times r over 1 minus r, because our last term and the first term are given in this given sequence. By substitution, we have s of 5 equals 3 minus 48 times 2 over 1 minus 2. Simplifying this part, 48 times 2 will have 96. So 3 minus 96 over 1 minus 2 is equal to negative 1. And then 3 minus 96 will be equal to negative 93 divided by negative 1. That will be equal to positive 93. So the sum of the first 5 terms given that sequence will be 93. Example number 3. What is the sum of the first 10 terms of 2 plus 2 plus so on and so forth? As you have noticed, our first term or a sub 1 is 2, and our r will be equal to 1, because 2 divided by 2 is equal to 1. And the number of terms will be equal to 10. So to find this, we have s of 10 as unknown. We use the formula s of n equals n times a sub 1, where n is the number of terms and a sub 1 will be the first term, since our r is equal to 1. By substitution, we use s of n is 10, so s of 10 equals, our n is 10 times the first term or a sub 1, which is equal to 2. So 10 times 2 is equal to 20. So in this given sequence, our series will be equal to 20. Example number 4. What is the sum of the first 10 terms of 2 plus negative 2 plus so on and so forth? Our given again, our first term or a sub 1 is equal to 2. Our r now would be equal to negative 1, because negative 2 divided by 2 is equal to negative 1. Our n is still equal to 10. We need to find for the sum of the first 10 terms. And to find this, we always have to apply s of n should be equal to 0, since our r is equal to negative 1. So the sum of these first terms given 2 plus negative 2 plus so on and so forth will always be equal to 0. And obviously, we have n as an even number. 10 is an even number. Example number 5. What is the sum of the first 11 terms of 2 plus negative 2 plus so on and so forth? Our given is, we have the first term or a sub 1, which is 2. Our r is negative 1, because negative 2 divided by 2 is negative 1. And our n is 11. In this case, we have an odd number of the value of n. We need to find for the s of 11. So we always have s of 11 is equal to the a sub 1. So in this case, we have s of 11 is equal to the first term, which is 2. Remember, our r here is negative 1 and our n is an odd number. That's why the sum of the first 11 terms given this sequence will be positive 2.